So a couple days ago, I showed how to thread the rim of a trumpet mouthpiece. Today, we're going to thread the underpart. We're going to do this on the lathe. So the threads that we need are going to be 32 threads per inch. And on my lathe, this is the configuration for 32 threads per inch. We're going to need an outside threading tool, which is a pretty simple tool. It's just your basic, got some dirt on there, a 60-degree flat on top, outside threading tool. Pretty simple. In addition to that, we're going to use, just your basic threading tool to cut the top off of a underpart. We have to turn the rim to dust. We'll use this to do that. So as a candidate for this project, I'm going to take this Schilke 6A4A, which I think is kind of a modern one. Never been modified. I'm going to cut the rim off. I'm going to destroy this and make an underpart out of it. I suppose it might be worth more if I leave it this way than if I make an underpart out of it, but it's a chance I'm going to take, frankly, to make this video. So I'll put it in the chuck. See, Schilkes have a nice flat spot right here. Kind of easy to grab. Center up real nice in the chuck. Not bad for the first little grab. Now we're going to get the indicator and run it. So since we're going to cut these threads and leave the cup intact, we want to center this mouthpiece to the inside of the cup, right about where the point of the seam of the mouthpiece is going to be. So, I don't know if you can see my indicator down there. It's really straight. It's to 1/10,000th. The straighter you can get that, the better. So, looks like we got a little bit of an issue here. In order to get this in the chuck good, let's see if I can see this. I had to grab it right here. That's where the flat spot was. That gets me pretty close to these jaws when I'm going to be turning this way. So, I may have to fudge that at the end of the process to get this last little bit. I can turn all this off and get right up to those jaws. But I don't know if you can see there's a little bit of a surface there that I'm going to want to take off that I might have to do after I'm done. So let's start cutting away at this. Okay, so I made a little bit of a cut, and then I measured this cut, and that's how I tell my computer where my tool point is. Because I have digital readouts on my lathe. If you don't have digital readouts, you have to measure these cuts every time to get it to the right size. But I have digital readouts, so when I cut, I know exactly where I am, this way and this way. And then when I switch tools to my threading tool, I'll know where I am then too. And that's actually quite cool. Oh, so as a drawing to see what we're doing here, the threads out are the major diameter has to be 750. They got to be 500 deep, and then this little thing right here has to be at 715. So 3 numbers to hit, easy. So the first thing we're going to do is shave this down to 750, 3/4 of an inch. I could have made bigger cuts, but see how I'm grabbing this piece? I'm only grabbing by like 1/8 of an inch right there. So if you're going to make really bold cuts, you want to have this workpiece grabbed really hard. And when there's that little to grab onto, I make a little bit, I don't make super big cuts. I'm making cuts of about 80 thousandths, which is pretty big. I mean, brass is easy to cut. I could go bigger, but I don't want to risk pulling this out of the chuck. And I don't want to clamp it down so hard that it makes a mark in there either. So 50 to 80 thousandths deep is, you saw how fast it goes. You don't have to rush. You have to make super big cuts. So here's my last cut. This is going to be 750, but I'm going to make it 748. Okay, now I have to make that little gap where I'm going to go down to 715, and that's my thread relief notch. Some people call it a thread relief gap. I'm going to do it with this same tool. And I took that down to 704. I might make it a little... So now I have to do one more thing, and that's bevel that. So I'm going to do that with a shaper. Cake. Now, I'm going to shave it down this way to the spot 125 from the top where the parts are going to meet. So now here we go. I should have probably made this groove a little bit farther that way, but there's enough threads there, really, and I didn't want to, I wanted to grab this as much as possible on this mouthpiece. I could have pulled it this way a little bit and still had something to grab, but I wanted it to be secure. So, and my threading tool can only get about that close to the jaws too. It'll work though. Now I'm gonna bevel this. I shouldn't have beveled that other time. When I did that bevel before, I got ahead of myself a little bit. So now I'm going to switch to this tool, outside threading tool. I just slowed my lathe speed down, my chuck speed, my spindle speed, to about 70, 80 RPM, 70. And set my threads to 32 threads per inch. Now I'm going to cut these. First I have to engage my thread nut. So here we go. I gotta stop that right when it hits here. Woo! Kind of dangerous. At first it's a little nerve-wracking getting that close to the chuck, but here we go. You'll see threads starting to appear, maybe. Bingo! See, there's a thread there now, a little bit of a hint of a thread. This is one reason you go slow, like 70 RPMs, because if I was going faster, that tool approaches the chuck pretty fast, and it's kind of nerve-wracking sometimes. You got to stop it right before it hits there. The slower you go, the better. So I'm shooting for about 715 on this diameter. This should be it right here. Since that was such a bold cut, I'm going to do it again, that same diameter. Just to clean it up a little bit. Bingo. I like to clean it with these scratch pad things. These are nice. Good for taking off any little burrs and things. But it should be threaded now. I think it's about the right size. I might have to make one more swipe. Let me get a rim. So I knew kind of what number I wanted to hit, which was 714. I went all the way down to 710. Makes a nice, because I went a little farther because if this ever gets silver plated, it needs to be a little looser when you start. Otherwise, the silver will fill up the space. Now that's really nice. That's smooth. Okay, that's good. Now I still have to encroach into the mouthpiece a little bit. Now that the threaded parts are good. All good with that. Don't have to mess with that anymore. Now I have to pull it out of the chuck and extend my cut a little bit. So now I'm barely being able to grab it. Let's see. I don't know if you can see too good. There's not much flat area for me to grab. Enough where I can make enough. I just need to shave this little thing off right here. I don't need to. I would not want to make the threads by grabbing that tiny little area of the mouthpiece. And so right now I got it to within 1/1000th, which is good. I had the mouthpiece originally to 2/10,000ths, which is really good. But for now, this is good enough because I'm not really doing anything critical. It's just exterior. And I'm going to cut that little nib off right there. So switching back to my main turning tool. Now I'm going to tell it where 0 is. There's 0. Now I know my tool knows that that's 0. So I'm going to go into 500 because this whole, as the drawing said, I want it to be 500 from there to where the end of the rim is going to hit. And I should be able to. No, not 500. 375. Sorry about that. The rim is a 500 thick, but this point where they meet is 125 from that side. So I'm going to go from here 375, and that's where I want to make that facing, the next facing. 375 is right there. So see what I have to do. To go right up to there. I might even go a little farther to get that whole little nib off of there. So here we go. There's 375. I'm going to go to 380. I mean, there'll be a 5/1000ths gap there. That's fine. See what that feels like. So there's a little bit of a ring right there. I might go just a tad farther and knock that little thing off. Getting really close to the chuck right there. See that little thing that just came off? There we go. Fantastic. I got a little shaving here that I got to break off of there. Sometimes you get that. Okay, so now we're done. See what it feels like. It's good. There we go. So now we'll pop it out and see how a mouthpiece, the rim that I want to put on here, see if it fits. I mean, this is kind of a random mouthpiece, and I'm putting the rim that I play right now, and it might fit, it might, who knows, but it's an experiment. Let me get a rim. Actually, I have a rim right here. This is the rim right here. Might be a mile off. And if it is, if I was going to use it, I would have to blend it, I guess, but wow, not too bad. Almost matches. You can see that I don't know if you can see that, but the diameter of the under part is a little smaller than the diameter of the rim. So if I wanted to blend it, I would put it back in the chuck and just carve the under part out a little bit until it met the rim. That's called blending the rim. But if I want to put this under part on another rim that is not this rim, then if I blend it to this rim, then it won't fit the other rim. So in this case, I think I would just play on that. That's entirely in the realm of what might work. It's about, looks like about 4 thousandths different diameter, which isn't bad. I could just knock that edge off a little bit. If I said I was gonna like this, and who knows, it might be great. Actually might really be good. We'll see. I'm gonna play it, and if I like it, I might blend that out. You never know. Anyway, that's threading an under part right there. Looks pretty good, actually. This is the rim that I threaded the other day, and this hasn't been silver plated yet, as you can see. Looks pretty nice. Oh, something I forgot to mention. I talked about this in the other video about threading the rim, but see how these parts match? If I wanted to really, this is kind of a shallow mouthpiece, and in a shallow mouthpiece, it's really important to get the depth exactly right. And that's one of the best things about a screw rim, is that you can do that by either facing off. If I want to make it shallower, I can just turn this down 1 or 2 thousandths, or turn the inner face of that down 1 or 2 thousandths. So whenever I do an under part, I always make it a little bit longer than I think I'm going to need, because you never know, you might like it. That if you make this longer, it means the under part is deeper, and maybe you'll like that, or somebody will like that. And you can always shave it down to get it right. But I always like to start and make it about 4 thousandths long, or maybe 5, maybe even 10, and then try it, with the idea being that you're going to dial it in. I usually don't do that with this, but you can also do that same dialing in process inside there, but it's harder to deal with. And every time you face that off, you remove a little bit of the material that's attached to the rim. And the material that's attached to the rim, the part of the cup that's attached to the rim, is usually kind of rim specific. That's what we call the alpha angle right there. And usually that's what you need to keep constant from one mouthpiece to another. And that's, of course, the other idea with a screw rim, is that this all stays constant, including that alpha angle. So anyway, that's the idea with a screw rim. The concentricity of this, by the way, is good. It should be, because I meticulously indicated the rim when I cut it. And then I really had the underpart straight in the chuck when I cut that. So the concentricity, the cup and the threads are concentric. So anytime I want to alter it, I just indicate to those two surfaces, either right inside the rim or right just in the cup right there. Indicate to those, and you can move it in and out of the chuck over and over and over while you dial it in, as long as you take the time to get it straight. And I have a video on that. So I hope you like this video. I'll have another one in a couple of days. There you go.